To solve any titration problem, you need to know the titration formula. And if you forgot how it looks, you can always find it in your trusty reference tables on the last page, table T. Here it is. Pay attention to the fact that Ma represents molarity of hydrogen ions, not molarity of an acid. In case of monoprotic acid, the molarity of an acid would be equal to the molarity of hydrogen ions, but it would be a different story if we would be talking about diprotic or triprotic acids. The same can be said about Mb, because it represents actually molarity of hydroxide ions, not molarity of a base. In case of monohydroxy base, yes, molarity of a base would be equal to molarity of the hydroxide ions, but in case of dihydroxy, trihydroxy bases, the story would be different. Take a moment to read the problem above. We are asked to identify concentration of the solution of hydrochloric acid, given the information that 20 milliliters of this solution of unknown concentration was neutralized by the solution of potassium hydroxide, and it took 50 milliliters of the solution of potassium hydroxide, and the concentration of the solution was 50 molarity. Hydrochloric acid is monoprotic acid, so in this case molarity of this acid will be equal to the molarity of hydrogen ions, and potassium hydroxide is monohydroxy base, and considering that, the molarity of the base will be equal to the molarity of hydroxide ions in the solution. So all that is left for us is to take our titration formula and plug in numbers: the molarity of hydrogen ions, the volume of our acid, molarity of hydroxide ions, and the volume of our base that was used to neutralize an acid. And then we solve it for x. So we found the molarity of hydrogen ions in the solution, and since we are talking about monoprotic acids, the concentration of hydrogen ions in the solution would be equal to the concentration of the hydrochloric acid. Once again, stop this video and read the problem. In this problem, we are asked to find out the concentration of the solution of sodium hydroxide, knowing that 10 milliliters of this solution was neutralized by the solution of hydrochloric acid, and it took 5 milliliters of the solution of hydrochloric acid with the molarity 0.2 to neutralize the sodium hydroxide solution. And since we once again have monoprotic acid and monohydroxy base, nothing is left for us but to plug in the numbers into the equation. And we solve it for x. So the molarity of hydroxide ions in the solution is 0.1, and since we're talking about monohydroxy base, that would be the concentration of the base in the solution. Stop this video and read this problem. Let's examine what we have. Well, we have the solution of sodium hydroxide, and here's the volume that we have, and we know the molarity of this solution, and we have
solution of hydrochloric acid with the molarity 2.5. So the question is, how much of this solution do we need to neutralize our sodium hydroxide solution? And since we are having monoprotic acid and monohydroxy base, the life is easy. We just need to plug in the numbers. And we're solving it for x. Three liters. To neutralize 1.5 liters of this solution of sodium hydroxide, we would need 3 liters of this solution of hydrochloric acid. Now, here's the new problem. Please pause this video and read it. Well, the story is the same. We have an acid, we have a base. Acid is of unknown concentration and we have the base of known concentration. We neutralize acid with base and find out the molarity, the concentration of the acid. But there is a little twist on it. This acid, sulfuric acid, is diprotic acid. When sulfuric acid is ionized in water, every molecule of it gives 2 protons into the solution. Consequently, the molarity of protons in the solution is twice the molarity of the acid itself. Keep this in mind because we will need this information later when we will be calculating the concentration of the acid. But for now, we just plug in numbers into our formula. And we solve it for x. So, concentration of hydrogen ions in the solution 0.625. Now, to find out the concentration of the acid itself, we need to divide it by 2. Because remember, we said that for diprotic acid, the concentration of hydrogen ions is twice the molarity of the acid itself. So to find out the concentration of an acid, we divide 0.625 by 2, and it will be 0.313. And that would be the molarity of the acid.